course in graphing lines. So we're going to graph this line y equals 2x plus 4 first by making an xy table. If you ever get confused with any type of what we call mathematical function, where we have two variables here, pick an x and a y, and you pick some values. It's always smart to pick a negative value, 0, and another positive value, and you substitute in, meaning you do 2 times negative 1 plus 4, which would equal 2. Then plug in 0. 2 times 0 plus 4 is equal to 4. And then 2 times 1 plus 4 is equal to 6. Now you have ordered pairs. Negative 1, 2, plot that. 0, 4, and 1, 6. Connect it to make a straight line. And I want you to notice now, what is the slope of this line? Well, if we were to count, the rise would be up 2, right 1. Our slope is 2. What do you notice about the equation? Well, this value, the coefficient in front of x, is your slope. How about the 4 from the equation? Where's that? That's the spot where it crosses the y-axis. That's known as our y-intercept. What is known as slope-intercept form of a linear equation is y equals mx plus b. M is just representing the number held to x by multiplication, and it is known as our slope. It's the same m we were previously talking about. B is the spot where it crosses the y-axis, or the y-intercept. We're going to graph some lines now. So the first one, y equals negative 2x plus 6, we're going to begin by identifying our m value, which is the coefficient in front of x, and our b value, our y-intercept, is 6. I begin by placing my y-intercept. Count up 6 units and put a point. And then I'm going to count my slope from that point, but I change it to a fraction, and then it's rise over run. So I'm going to count down 2, right 1. I do it again, down 2, right 1, and again, and I keep doing that until I reach the edge of my coordinate plane. I could also reverse directions and go up 2, left 1. Connect it. And this represents all the possible solutions or combinations of x and y that are solutions to that equation. Notice it's downhill because it does have a positive slope. All right, in our next one, our slope is 1/2, and our b value is negative 5. So this time I'm going to count down 5 units for my y-intercept. My slope is 1/2. So I'll be counting up 1, right 2. Up 1, right 2, and again up 1, right 2, over and over. I could also go down 1, left 2, down 1, left 2, till I reach the edges of my coordinate plane. Notice I do have a positive slope. It's uphill. Now, it would be awesome if lines were always given in slope-intercept form, but they won't always be. So, what you can do is change it to slope-intercept form by isolating your y. So I'm going to begin by subtracting 3x from each side, which gives me negative 5y remaining on the left equals negative 3x plus 30. Best way to write that is your x coefficient first. Now I need to get rid of the negative 5. It's held by multiplication, so I divide. I need to be sure I divide this entire side by negative 5. But what some students prefer to do is to divide each value by negative 5, which produces y equals positive 3/5, because a negative divided by a negative is a positive, x minus 6. Now I know my slope is a positive 3/5, meaning up and to the right, and my b value is negative 6. So I begin by plotting my b value of negative 6, and I count up 3, right 5, or down 3 and left 5. Connect. And that represents all the solutions to this equation. you're going to encounter some special lines, y equals 4. This has no x, so that means that the coefficient is 0. So this crosses the y-axis at 4, and it would be a horizontal line. You've probably heard me say in class, HOI, which remember stands for horizontal lines have a 0 slope and they're in the form of y equals. So when we have x equals -5, well, there is no y here. So this can't be written in slope-intercept form. All we know is that x is -5, so I go over to -5 on the x-axis. I place my point, and this means x is always -5. It can never be anything else, so we get a vertical line. You've probably heard me say in class, VUX. Vertical lines have an undefined slope, and they're in the form of x equals a number. Another thing you'll be asked to do is to find the intercepts. Well, if it's given in slope-intercept form, the y-intercept is easy to see. But I want to tell you, in general, intercepts, of course, are where lines cross the x and the y-axis. So, if we're finding an x-intercept, what I know is there'll be some x value, but the y will be 0. So what I'm going to do to find an x-intercept is I let y be 0. And then I solve my equation. So it would be 2x minus 3 times 0 equals -12. This is 0, so I just get 2x equals -12. Divide by 2, and I get x equals -6. So I let my y be 0, and my x was -6. So that's my x-intercept, and I'm going to plot that. I'm also going to find my y-intercept. Well, to find a y-intercept, I let the opposite letter. I let x be 0, okay? Because a y-intercept is where it crosses the y-axis, and it's in the form of 0, comma something. So I'm going to let x be 0, and I'll substitute in. So I'd have 2 times 0 minus 3y equals -12. This would be 0, so I'd get -3y equals -12. If I divide both sides by -3, I get y equals 4. So I'll place that intercept on the graph, and there is my line. I could count the slope if we were asked that. It goes up 1, 2, 3, 4, and right 1, 2, 3, 4, 5, 6. So my slope would be 4, 6, which reduces to 2/3. If you have any questions, please rewatch portion of the videos or reach out to me in class as you're working through your practice.